In this problem, what we're going to be looking at is we're going to be looking at redox reactions. So oxidation reduction. So remember, oxidation is loss of electron. All right, so oxidation, oil, rig. Reduction is gain electron. That's one way to look at this. Another way to look at this is also oxidation means it's gaining oxygens and reduction means it's losing oxygen. And so you can look at it one of two ways. In inorganic, we typically look at it in terms of gaining or losing electrons. In organic chemistry, oxygen means it's gaining oxygens. Reduction means, so oxidation is losing of electrons or gaining oxygens. Reduction in inorganic chemistry means that it's gaining electrons or losing oxygens. And so that's a couple ways of looking at it. We'll try to look at it in both cases in this problem. I'll do my best to try to explain it. If you have any questions, once again, just let me know. And we'll get through it. Some of this is kind of weird because to think of ammonia as ionic is kind of strange because it's actually covalently bonded. And so in this problem, what we want to do is we want to say identify the oxidizing agent and the reducing agent in each of the following reaction, and explain your answer. So remember, what is being oxidized is the reducing agent, and what is being reduced is the oxidizing agent. Now in this case, the oxygen, we're not going to be looking at the oxygen. What we want to deal with, we want to deal with the nitrogen and the hydrogen. And so the nitrogen in this case is going to be, we're going to look at the hydrogen. Let's look at the hydrogen first, all right? So we're going to look at the hydrogen first. Now if we look at the hydrogen, because the hydrogen is a little bit easier to deal with because we simply have just the hydrogen on only one of the reactants as opposed to nitrogen on both. If we look at the hydrogen here, the hydrogen from the reactant side going to the product side, the hydrogen is gaining oxygens. And so the hydrogen is oxidized. And I'll go in a few minutes. So what do I mean by that? Well, it's a little strange, but here the hydrogen is going to have a -1 charge. The hydrogen is going to have a -1 charge. And over here, the hydrogen is going to have a +1 charge. In order to go from -1 to +1, it has to lose electrons to become more positive. And so thus, it's going to be oxidized. Another way of looking at that is that it is being oxidized because it is gaining oxygens. So it is oxidized. Since it is oxidized, it is the reducing agent. It's the reducing agent. Now we look at the nitrogen. If we look at the nitrogen here, the nitrogen is reduced. Now a way we can look at that, and we can look at this nitrogen here in particular, is if we look at this nitrogen in particular, it's losing its oxygens. It's losing its oxygens. So it's going from nitrogen bonded to hydrogen to just being nitrogen to itself. Okay. That's one way we can look at it in terms of it losing oxygen, so it's being reduced. Another way we can look at this is we said that the hydrogen here is going to be a -1. I know it seems a little strange because we look at hydrogen in the +1 column, in the first column, say that's going to be +1. But remember, the hydrogen can also be above the halogens as well too, where it would have a -1 charge. In that case, it's a hydride. So if this is -1, this becomes +3. Now oxygen is -2. And in this case, it's +4. So we have a +3 and a +4 nitrogen. Over here, we have a 0 nitrogen. So in this case, nitrogen has 0 charge. In both cases, if going from +3, +4 to 0, it is being reduced because it has to gain electrons in order to go from +3, +4 to 0. And so it is being reduced. So nitrogen is being reduced, or it is the oxidizing agent. All right. So a couple ways to look at this. You can look at it in terms of the charges, which in this case is a little bit harder because these are all covalently bonded, or polar covalently bonded. Or you look at it in terms of gaining or losing oxygens. All right. If you have any questions on this, please let me know.